Good morning and good afternoon, RSGA, and whoever decided to watch this video. And you guys are in for a treat because in this lesson, we are going to explore motor vehicle motions, the basic physical science principles of engineering and automotive motion. Now, this video series is going to be in multiple parts. So this is going to be an introduction and part one. But you know what the really cool thing is? If you're in my class, you already know that I run a YouTube channel about restoring classic cars and doing some basic automotive how-to. So you are really learning from not only a teacher who knows STEM and multiple other subjects, but from someone who's a fair expert in the field. So you don't want to miss this. So I'm going to go ahead and cut my picture out, and we're going to focus here on the slides. So for this first introductory video, we're basically going to look at automotive motion at its simplest. And what forces do, well, automotive vehicles need to overcome, right? So we're going to start with one of my favorite motor racing sports, drag racing. Check out this video.
John Langdon was 56 on the tree, but a 367.5, 337.75, Tony. It is unbelievable the speed they're getting out of this car. Antron smokes the tires, and Brittany Force 368. Look at the speed. 337.75 miles an hour, one of the fastest runs in the history of Top Fuel drag racing, and a de facto track record at Gainesville. Steve Torres is 39, but Brittany's swinging with him, and it's Brittany Force. Wow! 371.8, 338 romping, stomping miles an hour. What a race down to the finish line stripe. It is matching elapsed times to the thousands. It'll go down as a whole shot for Matt Hagan. A 15 reaction time for Matt Hagan moves him to the final round. As Brittany Force goes 366.5 at 338.43. That is an incredible run, and it is the fastest run in the history of Top Fuel drag racing.
How about 3.641? 338.94 miles an hour. Brittany just went 297.94 to the 8th mile, goes to number one, sets the record.
Now, as you were watching that video, I hope you were thinking about Newton's first law of motion. Remember, objects in motion stay in motion unless acted upon by another force. Well, not only was Brittany Force featured in those videos, along with her father, John Force, but forces that act on a car on Earth include engine forces. They convert potential and mechanical energy into energy that moves a car forward, right? Usually we measure that with horsepower and torque. You got friction energy, a force that prevents movement. This may include things on a car like tires and air and moving parts and brakes and road surface conditions and other environmental conditions like snow or wetness and what have you. And of course, you have gravity pulling the car down, a constant pull towards the center of the earth. This force is overcome with, well, roads, bridges, and sometimes we want to reinforce gravity by adding extra aerodynamics to keep the cars planted as they are moving at really fast paces while doing things like racing and such. So, Here's a really good way to think about things, right? Think of a parked car or a stopped car as having balanced forces. Remember, nothing is acting upon it to make it move forward or to move backward or make it go side to side. Think of a car that is moving in a straight line and slowing down as having, well, unbalanced forces, right? If it is moving in a straight line, something is acting upon it to make it move forward. If a car is slowing down, no matter what the rate, something is acting upon it to make it slow down. Remember, the key here is that objects in motion stay in motion unless acted on by another force. Let's go ahead and summarize things with a last quick video.
The forces on a car. When a car is stationary, it has two forces on it, the weight force, which is the force of gravity pulling it down, and the normal force. This is a force provided by the road surface pushing up. These forces are two equal and opposite paired forces. If we want to move the car forward, we have a driving force. This is provided by the engine. As the car moves forward, it will have resistance forces acting upon it, mostly by friction. If we have the driving and the resistance force equal and opposite, then we have no overall forces on the car, and therefore we travel forward at a constant velocity. No force means no acceleration. Therefore we have constant velocity, unchanging speed. The resistance forces are mostly composed of air resistance, road friction, rolling friction, and braking forces. If we go back to our car with its forces and we see that the driving force is greater than the resistance force, then we must have an overall net force in the forward direction. If we have an overall forward force, therefore we have acceleration in the forward direction. If we have a resistance force which is greater than our driving force, then we have a situation which is braking. If there is no driving force, we'll eventually make the car come to a complete stop. If when we're driving down the road, we pass over a patch of oil or any other surface which can be lowered in resistance, say for ice, then we have lowered traction between the surface of the tyres and the surface of the road. That means we have lower driving force. That means that we could either have no forward driving force or very little. The only forces that we could have on the car to try and stop us are the backward resistance forces. We couldn't have any road friction, but we can have air resistance to bring us to a halt. We now are driving down the road and we're going to accelerate a slight bit. So we're going to have some more forward driving force. We now encounter an angled road. That means the normal force, which always has to act at right angles to the road surface, will change. We also need to drive up the road, so we start accelerating up the road. Our resistance forces are the same. So these are the arrangement of our four forces. The combination of the resistance and the weight force being slightly angled towards each other now creates a net force down the slope. This means if we wish to climb the slope with a constant velocity, we need to depress the accelerator pedal to increase the driving force up the slope.